We spoke about a non-linear function. Okay, what is a non-linear function? It's not straight and it's a parabola. Okay, so your non-linear functions will look like this. Okay, we saw this example earlier. We know the minimum, or in this case the maximum, occurs at 12.5. Okay, how can we get this amount? Well, we can get it by using b over 2a minus b over 2a, and that was the x value of the turning point. Okay, so the x value of the turning point can be used, can be calculated using that. Okay, all right. So if I'm looking at a tangent to this line, okay, a tangent will have a gradient. Do you agree? I can draw lines against the side of the let's say circle or semicircle, and those slopes are going to be what? Positive or negative? Positive. Okay, so m on this side will be plus. If I had to draw a tangent against those, what would the m be? Negative, correct. So at some point in time, right at the top there, the slope the slope becomes positive, 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 positive until flat, and that's 0. Okay, and then it becomes negative and it starts sloping down. All right, so can I use calculus? Can I use a derivative to find the slope of the graph? And the answer is yes, you can. Okay, a derivative can help you find that minimum or maximum. Okay, so we first need to know how to find a derivative. Okay, so the normal function can be given like that. Y equals xn. Okay, if I'm looking at a derivative, they use this notation. Okay, dy over dx. Okay, so y in terms of the function derived in terms of x. Okay, that's the notation. Right, and that's how you get the derivative. Right, so that's the function and that's the derivative. Okay, so simple example, x squared. Okay, if I write x squared, that's the function. To get the derivative, I take the 2 and I multiply it by the number in front of x, which is what? Which is 1. Yeah, there's an invisible 1. So you'll get 2x, and then what do I do to the exponent? I minus 1. Alright, so your answer would be 2x. 2 minus 1 is 1. We don't write 1s as exponents, we just write it as 2x. Okay, so the derivative for 2x, x squared is 2x. Okay, does that make sense? Alright, so here's the list of values to try. Okay, y equals x3. What would the derivative be? It'll be dy over dx equals 3x squared. Good. Good. Okay, the next one? Dy over dx?
5x to the power of 4.
Good. 5x to the 4. What else? Next one?
Half minus 1.
Half x? A half minus a half is what? No. A half minus a half. A half minus, okay, I said a half minus half is nothing. A half minus 1 is what? Minus a half. Yes. Okay, minus a half. Okay. Should you write exponents like this? No. If you've got a minus, what does that mean? Denominator. Okay, so x to the minus 1 is what? 1 over x. Okay, so x to the minus a half would be 1 over x to the half. Right, x to the half is the same as root x. Okay, root x is the same as x to the half. Okay, is that right? Okay, this one.
Minus 1 becomes minus 1x.
Yes. Okay, again, do you write things like that? No, you don't. You should write this as minus 1 over x squared. Okay, so you might have to convert your answer to choose the correct option. That's the point I'm trying to make. Okay, the last one.
Minus 3x minus 4.
Correct. Simple, eh? And this is derivatives. Okay, you're differentiating a function, okay, to form a derivative. Right, what happens if I have numbers though? Same thing applies. 3 times 5 is 15. X, 3 minus 1 is 2. And that's the derivative. Dy over dx would be 15x squared. Okay, if I have other variables, if I have an s here, then you'll have ds. ds over dt. Okay, ds over dt will be what? 5 times 2 is 10. 5 minus 1 is 4. And that's the derivative. Okay. Next one. What's the derivative of this one?
It's half times 10.
Is? So dx over dy is what? Half times 10 is what? Half times 10. Half of 10 is 5. Do you agree? Okay. Y to the what? Half minus 1 is what? Minus a half, yeah. And that's how you do a derivative. Okay, if you have a constant, like we have here, what happens to constants? When you find a derivative, the constants fall away. Okay, so it doesn't matter what constant I have there. Okay, the derivative, so dy over dx for this one will be minus 5x to the minus 6. Okay, what's the derivative for the last one?
Minus 1. Minus 6 times minus 1 plus 6, 6x minus 7.
Correct. Good. And that's how you do it. Okay. Right, let's have a look at derivatives of derivatives. Okay, so that's the function. If I find the first derivative, it's going to be 5 times 120, which is 600. Okay. Minus 2 times 100 is 200. Oh, I forgot the q squared there. Sorry. Forgot the q here. Okay. Q to the 4. Then minus. Okay, then q to the 1. Okay. Plus 0. Alright, so 600, okay, I didn't write it in, 600 q4 minus 200q would be the derivative, the first derivative for that function. Yeah, does that make sense?
Yes.
Okay, a derivative of derivative, so the second derivative, if I derive the derivative, I'm then going to get 2400 q to the 3 minus 200. That's the second derivative. Okay, and if you really wanted to, you could go further. Okay, we're only going to be using first and second derivatives. Okay, the first derivative finds the min or max. The second derivative tells you if it's a smiley or happy or sad face. Yeah. Okay. What would the third derivative be? Derive that. 3 times 2,400? 7,000? 200. Okay, q to the 3 minus 1 is 2. Good. Okay, remember constants fall away. You won't have a derivative for 200. Okay, and that's the end. Okay, you could even go further if you wanted to, but we won't. Alright, so now how do we use derivatives? Well, when you've been given total cost or total revenue functions, okay, we can calculate the marginal revenue and the marginal cost from the total. Okay, so if you derive the total cost function, you get the marginal cost function. Okay, so there's the note about it. Okay, marginal revenue is the derivative of what? The total revenue. Okay, marginal cost is the derivative of what? The total cost. Okay, if I'm looking at an average revenue over cost, then I'm going to just take the average revenue and divide it by the cost. Okay, so sometimes they give you strange formulas, but they'll mention what it is. Okay, and then we just need to apply our mathematics. Okay, there's a note about getting the minimums and the maximums. Okay, so earlier on, we saw a x value of 12, 5. And what was that? That was the position where the minimum or maximum occurred. Do you agree? There's it there. Right, so let's find the derivative. What is that derivative? Give me the derivative of this function. So in other words, dtr over dq. What is dtr over dq? 50? No, the q falls away. Minus 2 times 2, 4q. That's it. Okay, so now that's the derivative. 50 minus 4q. Okay, so now what do? I make the derivative equal 0. If the derivative equals 0, I get the minimum or the maximum. Okay, so have a look at this. 50 minus 4q equals 0. Take the 4q across, 50. Okay, divide by 4, divide by 4. What is q? 12, 5. Okay, so this and that are the same. Okay, so now we know how to use a derivative to find a min or a max. And that's how we're going to do it. Okay, because it's easier. Okay, a derivative is actually better because you take a massive function and you're simplifying it. Well, simplifying it because you're making the exponent smaller. Okay, and that's the derivative. Is that okay? Alright, so I want you to find the turning point of this. So, what do? Derivative, dy over dx is what? Correct? Yes. Correct. Okay, now how do I get the minimum or the maximum? I make this equal to 0. X is 3. Okay. Alright, so do you agree, if I had to draw this line, this graph, okay, I'm going to have that as the turning point. Okay, the x value of the turning point. Okay, sorry, that's not a straight line, but anyway, okay, that's the x value. X equals 3. Okay, that's the turning point. That's this line of symmetry. Okay, make sense? Alright. What do we use the second derivative for? Well, here's the note. The second derivative tells us if it's a minimum or a maximum. Okay, because remember we had this. Now, is the graph sloping that way or is the graph sloping that way? Okay, there's still a minimum and a maximum at the same point. We just don't know if it's happy or sad. Okay, so how do we do that? We look at the second derivative. Okay, so evaluate the turning point. Okay, what was the first derivative? dy over dx was what? We just worked it out. 6x minus 18. Okay, what would the second derivative be? So d2y over d2x would be 6. Okay, because the x would fall away. Okay, so if your derivative is 6, is that happy or sad? It's happy because you've got something. Okay, positive is happy. Okay, so if it's positive, it's happy. And if it's smiling. Okay, if it's smiling, what will you have? You'll have this, a minimum. Okay. Alright, if it's sad, i.e. if it's negative, okay, then you've got this scenario. Okay, it's sad. So what will you have there? It'll be a max. Okay, is that alright? Okay, so there's only one thing that you need to remember here, or two things. A derivative is used to get marginal, so you get marginal revenue, marginal costs. Okay, and you also use derivatives to find what? Minimums and maximums. Okay. Alright, so now we've just looked at derivatives. What is integration? It's doing differentiation backwards. That's what it is. Okay, so derivatives is moving forwards, integration is moving backwards. So now we've got the derivative, we want the function. If that makes sense. Okay. Alright, so how do we do this? There's the rule. This is differentiation. So if I go from the function to derivative, I make it smaller. Okay, we saw this not so long ago. Okay, a few slides back. This is integration. It's the opposite. Okay, it's the reversal. Okay, and that's the formula or rule that's applied. Okay, that's the rule. Alright, so when approaching integration, you need to know the general rule. Okay, so let's apply that to what we've got here. You know that x squared is 2x. Okay, if I'm using integration, what am I doing? I'm going from 2x back to x squared. Okay, so what do? I apply the rule. Okay, so I write down x squared. Okay, that's the function. Right, what do I do to the function what do I do to the derivative to get the function? I have to add 1 to the exponent and divide it by that number. 2 plus 1. Okay. Sorry, I'm looking at the wrong thing here. This should have been 2x. Okay, not x squared, 2x. Okay, so I would have a 1 here, 1 plus 1 over 1 plus 1.
So now we're going from making it from
derivative to function.
Derivative, we got the x squared and we made it 2x.
Yes, that's the derivative. We're deriving the function.
Now we're going
backwards.
So
now
they will give us 2x and say integrate it.
Yes, yeah. So that's correct. So you're starting with 2x and you're asked to go back.
Okay.
Correct, yeah. Okay, so then there's the steps. There's the 2x. So this is the integral. That fancy symbol is for integral. Integral of 2x dx. Okay, you're differentiating in terms of x. So I write down the 2. The 2 doesn't change. Okay, I write down the x. I then add 1 and I divide it by the 1 plus 1. Okay, obviously you can have any constant. Why can you have any constant? Because any constant will fall away when you find the derivative. Okay, so it didn't matter. Remember we had this example here. Okay, that fell away. That fell away. So it was just a plus c. It can be any constant. It doesn't matter what the constant is, it's going to fall away at the end. Okay, is that alright? Good. Okay, so here's a nice practice exercise. I want you to quickly write down all the derivatives. Okay, so give me the derivatives for all of those in that column.
Let's say now.
You can?
Okay, the first one I got 12x squared.
Next one.
10x to the power 4.
Next one.
Negative 6x to the power negative 4.
Good. Next one.
6 minus 30t to the power minus 1 to the power 4.
Correct. Next one.
That's 2x.
Good. Next one.
That is 3x and minus 10x.
Minus 4. Oh, you didn't finish the second last one. You said 3x to the power
Oh, okay, that's what I said.
minus 4.
Yes.
Okay, and then the last one.
And the last one is minus 10x.
No.
Oh, positive, sorry.
Yeah.
Minus 10x to the power of minus 11.
Correct. Okay, so now you know. So you're good at doing the derivative. You can move from function to derivative. Okay, the integration is what we're looking at here. Okay, so I'll do that step. Okay, so what do? We write down the integral of 12x squared. Okay, dx. That's how you write the integral. Okay, so what must I do? Equals. Okay, so the rule says, what do I do? Okay, now watch this. Watch this. I write down the 12. I write down the x squared. Okay, that's what I do. Then you do this. The rule says I plus 1 here, and I divide this whole thing by the 2 plus 1. Okay, that 2 plus that 1. Okay, is that alright? Okay, so then the next step would be what? Well, plus c. Okay, so what is 12 divided by 2 plus 1? Is what? 4. Okay, what is x to the 2 plus 1? X to the 3. Okay, and then plus any constant. Is this the same as that? 4x to the 3. Yes, 4x to the 3, because the constant falls away. Exactly. Right, and that's how you do the integration. Okay, I'm moving backwards. Okay, did you get that?
Let's try this one.
Yes. You did do integration at school, right?
Yeah, I did.
Oh, you did. And calculus?
Yeah.
Yeah, okay, good. So you should be more familiar than some. I've had students in the past that have done maths literacy and then they do this. Yeah, so for them it's quite a challenge. Okay, but we get there eventually.
Yeah, but then you have a constant estimate.
Well, yeah, I mean, it just depends. Like, yeah, there wasn't much interest for this module, so I've chosen to do the workshop option. Did you get a distinction in matric for maths?
No.
Okay.
So how do you found it?
Okay, so let's check. Alright, so this is how you would do the next one. Okay, I write down integral of 10x to the 4 dx. Okay, equals. Right, the 10 I don't do anything to it, so I just leave the 10 there. Okay, the x to the 4 I write down x to the 4. Okay, and then I need to do what? I need to add 1 to the top and I need to divide it by the 4 plus 1. Okay, dx. Alright, so then 4 plus 1 is 5. 10 divided by 5 is 2. Okay, x, 4 plus 1 is 5 plus c. Okay, did we get that one? Right, is that the same as the initial function? Must be. Okay, so, and that's what I would challenge you to do. So I would challenge you to complete the table because you've got the answers. Those are the answers you should get there. Okay, if you can get to the answer doing all the middle steps, then you know how to do the integration. Okay, but there's the answer. Those are all the answers that you should be getting. Okay, obviously these will be x squared plus c. And this will be minus x to the minus 3 plus c. Okay, you won't get the 60 and the 25, the 200, but you'll get a plus c. It doesn't matter what they are because they fall away. They're not important. Is that okay? Alright, and then the last bit is a few rules and then area under the curve. Okay, and that's it. That's your DSC 1520. Okay, then we can look at assignment 3 and a past paper. Okay. Alright, so some of these rules can be useful, okay, but you don't have to use them. It's up to you. Okay, the most important thing is you must simplify this as much as possible to get it in a format like that. Okay, I can find a function using that. I can't find a function if I had something like this. Okay, what would I have to do? I would have to get rid of the brackets. Okay, so you first get rid of the brackets, you make it look like that, simple, without any brackets, without any pluses and minuses, and then you can integrate. Okay, right, so if I have a constant, whether the constant's part of it or whether the constant's outside, it's not going to make a difference. Okay, the 100 can be there or the 100 can be there, I'm going to get the same answer. Okay, same thing here. If I have an integral where I've got two separate components, okay, if I do it as one, that's fine. If I split them in two and then I do it, that's also fine. Okay, you can split the question into two, okay, because the pluses and minuses separate the terms. All right, again, there's some examples that I want you to look at. Okay, in the textbook 435, we're going to do the we'll do the assignment. We'll do the assignment. Okay, not assignment and the past paper. Okay, right. Here's the last note about how do I use integration. So, what application, okay, does this get used for? Okay, and here's the answer: finding the area underneath a curve. Okay, so you've got a function. Okay, this is the notation that's used. And what is this notation saying? It's saying find the area under the graph from A, which is here, okay, to B, which is there. Okay, it's a definite integral. Okay, so you're looking at that. What is the area under the graph? Okay, if I have the function, I can then work out the area under the graph, because it will then be B, okay, the function of B minus the function of A. That's what you're looking at. Okay, so how do I do that? Well, here's an example. There's the question, okay? Evaluate the definite integral, okay? X plus 2 dx. Okay, so what do? I can split it, or I can leave it separate. It's not going to matter. Okay, just a tip. You know, when you have 2x, when you have 3x, when you have 10x, okay, if I had to find the derivative of each of them, what do? I drop the x. Do you agree? If I'm finding the derivative. Derivative of 2x is 2. Derivative of 3x is 3. Do you agree? Okay, so with integration, okay, I've got a 2 here. What do I do to get the function? I just add an x. Okay, I drop an x when I want the derivative. I add an x when I want the integral, the function. Okay, and the reason for that is because of this. Okay, this 2 is there. Okay, what is x to the power naught always? X to the power naught is always 1. Okay, so there's an invisible 1 here. Okay, x to the power naught plus 1 over naught plus 1. Okay, gives you that 2x. Okay, you don't have to worry about that middle step. They don't really show the middle step. Well, okay, for the written questions, so assignment 2, they would mark workings, but we didn't see any integration there. In the exam, when your assignment, they're not going to mark steps. They're going to mark the final answer. Okay, choose the correct option. Okay, so just remember, you just add an x if you're working out backwards. Okay, you drop the x if you're working forward. Is that alright? Okay, so now you've got the function. Having derived this, okay, which is the derivative, I'm now going back to the function. There's the function. Okay, so now what do I do to get the area under the graph? Well, I had A and B. I'm going to have to put B in here, and I'm going to have to put A in there. Okay, if I put A and B, I get a value, and there's it there. Okay, so what is f of 3? It's 10, 5. What is f of 1? 2, 5. Okay, this minus that gives me 8, which is the area under the graph. Okay, so if I had to draw that, I would put A here, or A is 1, and I would put B here of 3. Okay, because it actually should be an x. Okay, x and x. Okay, x 1 2 3. Okay, is that alright? Happy? Okay.